So hello to all our alumni and friends of the University of Toronto Faculty of Applied Science and Engineering tuning in from near and far. From your registration information, we are delighted to see that we have alumni tuning in from all over the world, including 5 different countries: Canada, US, Hong Kong, Ireland, that's a first, and Israel, I think, is a first. Welcome to everyone. My name is Sonia DeBulio, and I'm the Director of Alumni Relations for the Faculty of Applied Science and Engineering. And thank you for joining us here today for our February School Lunch and Learn presentation. Today, we're featuring Professor Tim Bender, from the Department of Chemical Engineering and Applied Chemistry, who will talk to us today about the Sustainability Lab, accelerating environmental research and education. You'll come to learn how U of T Engineering is doing its part towards sustainable development and our collective brighter futures. Before starting, I wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. Just a quick housekeeping item. You may have noticed we've moved our Lunch and Learn platform over to Zoom for today's event. We kindly ask that you make sure your camera and mic are turned off during the presentation and Q&A. If you have a question, please send it through in the group chat section. Doing so will help us make sure we can give you all the best experience for viewing and presentation without interruption. We have admin staff who are pulling together all of your questions so they don't get lost, and will help our speaker get through as many as possible during the Q&A period, which will be conducted at the end of the presentation. Professor Bender has kindly agreed to answer as many questions as possible. While we'll close the formal portion of the program at 1, Tim has agreed to stick around for a few extra minutes to answer any additional questions. Now, without further ado, it gives me great pleasure to pass the reins over to the chair of the School Lunch and Learn program, Lori Hevola. Lori is an Electrical 65 graduate and one of our most dedicated and engaged members of our alumni community. Lori has been chairing the School Lunch and Learn program for several years and continues to generously give his time to help continue the tradition in this virtual event space. And with that, I will pass it over to Lori to welcome our speaker for today's event. Thanks, Lori.
Thank you, Sonia. We are excited to have Professor Tim Bender join us today. Professor Bender is cross-appointed between the Department of Chemistry and the Department of Materials Science and Engineering, as well as being the Associate Chair of the Department of Chemical Engineering and Applied Chemistry. Today, he will be giving his presentation on the Sustainability Lab, which is a major initiative for U of T Engineering. We have received a very enthusiastic response to today's presentation, and so we are excited to have him join us here today to share this important work with us. As Sonia mentioned, at the end of today's presentation, we will have time for questions and answers. Thank you to everyone who has already submitted questions during registration. You are also welcome to ask questions in the group chat at the bottom of your screen, as Sonia mentioned, and then we will have Tim answer as many of those as possible at the end. Since his appointment in 2006, Professor Tim Bender's laboratory has focused on the design, synthesis, and engineering of new materials for application in organic electronic devices, including organic photovoltaics and organic light-emitting diodes. His research contributions span from fundamental aspects of chemistry to applied chemistry, to physical chemistry, and to the study of basic optoelectronic properties of organic electronic materials within organic electronic devices. He serves also on several internal and external committees, including as the chair of the steering committee of the Institute for Sustainable Energy, and has received numerous teaching awards during his time in chemical engineering. He obtained his PhD in chemistry from Carleton University in 1999. And so without further ado, Tim, we turn it over to you. Thank you for being with us today.
Well, thank you for the introduction, and Again, I'd like to say that it's a pleasure, frankly, to be with this set of alumni from the Faculty of Applied Science and Engineering for today. So I'm going to start by actually standing and showing you what I'm actually wearing for today. Is this shirt that my students have given to me, that my home is really the Wallberg Memorial Building. And here is my shirt for today, to give you a sense that I truly love my time within the Faculty of Applied Science and Engineering in the Department of Chemical Engineering and Applied Chemistry. And to start this presentation, and Lori had highlighted my background and credentials, and I'll just add a few things to them here, is that within my time at the University of Toronto, I've had over 100 HQPs come out of my laboratory, whether this be at the undergraduate, graduate, or postdoctoral level. And we have together published more than 100 publications into the field. And if we go back to my industrial days, I even have generated intellectual property and patents here at the University of Toronto, and have recently been highlighted internationally as the top researcher in the macrocycle and thalcynine space across the world. Now, one thing I would like to highlight to you alumni is that as I got my doctoral degree at Carleton University, it was because I went there largely to start as an undergrad because I was going to be a varsity athlete. Then definitely focused on chemistry, but then became very interested in chemical engineering and ultimately was moved forward into industry, when actually at that time I had the opportunity to apply for professorship at the University of Waterloo as well. Pardon me. So I had this time at Xerox Corporation where then I transitioned from being a basic chemist to a chemical engineer, and I am now licensed actually. And at that time actually had more than 60 patents that were issued at the US level to me, and was given an award because I had more than 40 US patents under my age of 40 at the time. And that was the first award ever from Xerox Corporation, because I was the first one under 40 to ever hit 40 US patents. So if you happen, and I'll just briefly talk about my industrial background, if you have a Xerox laser printer right now, you may have my technology literally working for you. Now, of course, we're in the virtual era slash electronic document era, so maybe you don't have significant, printing and hard copies and such. But if you actually have photoreceptors inside of a Xerox laser printer, this could be my technology, and this is what I did develop back in the day, and became very, very interested then in the organic electronics space. And back then, I even developed the photoreceptors, worked with multiple partners within Xerox Corporation out of Rochester, New York, and out of Japan to actually bring the technology to market to upscale the engineering, chemical production, and other aspects of it. It was a really fun time. But on the flip side, I was then very interested to come back to academia to help develop people. And that's when University of Toronto recruited me to come forward. So as alumni, I'd like to welcome you back to Toronto. I suspect that not everybody around the table today currently lives in Toronto or the GTA, but had this great experience when you were back in Toronto. So here's currently, based on Google Earth, here is the west end of Toronto, and I want to let you know that I live out in Etobicoke, which is that green round point that I put there for you near Pearson International Airport, and it's really nice. I tend to ride a bicycle down to campus downtown, and we're then going to fly around downtown, get closer to the University of Toronto St. George campus, shown here. What is highlighted here is the Wallberg Memorial Building as we're flying in as a drone, or however we are flying. And here is the Wallberg Memorial Building that if you are ChemEng alumni, you may be intimately aware of, or if you are our alumni in the Faculty of Applied Science and Engineering, here is the engineering quadrant, very near to the convocation hall and other aspects. And what is really important, as we're now talking about the SLab, is that the Wallberg Memorial Building is this entry point in the southern part of our campus and is the major entry point to our campus. So the engineering quad is really the entry point of campus, and so it's not just engineering students that enter through here, but arts and science or other students. And here is the Wallberg Memorial Building that I suspect a lot of you remember and recognize. If we go towards the west end of it, here is my office on the second floor, and then I'm going to start telling you about the SLab. So here is what the Wallberg Memorial Building looked like when it was first built in the 1930s. And you can see that it is a three-floor tall building, but was actually engineered to have 4 floors. And so what has been nice since even back then is we've had the opportunity to build the 4th floor onto the Wallberg Memorial Building. And then this is relevant to the SLab that I'm about to tell you about. So to start into the SLab, here would be the entry point to campus, and on the left-hand side, there is the 4th floor onto the Wallberg Memorial Building that is the SLab. So as we are going to be building it, and here you are walking onto campus, what is really, really important of this aspect is that anybody walking onto campus, or if it is even the Toronto Society that is just coming past this building, everybody will be able to see this. Wow, look at this this sort of addition to this building. It looks really interesting. There's a solar panel there. It's clear then that the University of Toronto is focusing on sustainability and energy generation and energy harvesting and all of these aspects of sustainability. And so here is another picture of it as we're looking up again, and you can see here's the SLab that we are planning to build. And this is a virtual picture. It's not yet built, and I will give you some more example of that. But here is the SLab that we're going to be having. And our goal for this sustainability lab is this is not just going to be chemical engineering and applied chemistry, but rather what I've identified as the co-director of the Institute for Sustainable Energy within the University of Toronto is that it is very clear that as we are addressing sustainability aspects, and not just in the chemical engineering space, but whether it be other aspects of civil engineering or mechanical engineering, that it is really important to have this cross-disciplinary area available. So yes, myself and Grant Allen, who's the chair, and I'm the associate chair of chemical engineering, have been leading this, let's say, design, but also leading the idea that it's very clear that we need to have space where cross-disciplinary people can get together. For example, a chemical engineer, an electrical engineer, and a mechanical engineer can get together for collaborative projects so that we can actually go forward with whatever aspect we're talking about when it comes to sustainability. So it is not our specific space, even though it is in the Wallberg Memorial Building / will be on the Wallberg Memorial Building, but it is not specifically our space. And here's another one as we're just looking from another angle. And you can see that we've even engineered and designed with the architects that we've been working with on a way that this SLab has a net zero energy footprint. So for example, you can see we want to have a lot of photons coming in so that we don't have to have electrical sourced lighting, for example. And we're going to be having a solar panel up there so that we can generate electricity. And as we're needing electricity to conduct research and development, that we have a net zero footprint, and that is our goal. So for this nice group that has joined us today, now I'd like to go forward and show you the design that we have done. And here's the 2D design. And you can see that we're going to be on this end point of the Wallberg Memorial Building on the east end. And I'd like to show you then that the space that we're going to have is going to have 2 specific areas of collaboration. One being a wet lab, whereby if we are doing chemical processes or mineral refinements or other things that need significant safety aspects, that we're going to be having the right-hand side called the laboratory. And that will be a highly versatile laboratory space. The way we have designed it, as even as you can see, for example, 5 benches along the right-hand side, all of those benches are flexible. If we were to engineer a particular unit that needs to be in this space, we can move these benches. We have all the resources, or in the design, we have all the resources, whether it be electrical connection or other and gaseous connections, in order to have high level of versatility. And that's what we really, really need for the SLab, is this high level of versatility, because as we're going forward with sustainable research and development, it can go in ways that we don't even predict up at the front point, but rather ends up in this point. Therefore, we're redesigning something and moving it forward to the market, and therefore need the space for it. On the left-hand side of this design space is the so-called office and collaboration point, whereby if, for example, we are collaborating with somebody that is using significant computational modeling, whether it be the artificial intelligence or machine learning, this is an area where it's still a collaborative space, but where we don't need that safety aspect. And so we have really distributed the space across multiple areas so that we can have, again, this multidisciplinary research that uses very different approaches to address these aspects of sustainability. And here is the 2D view of it, where you can see just the labs and the general height. And then one thing I really want to also highlight, and we have double checked this is unique. There is no other rooftop research platform laboratory available in Canada at any other universities. And I always had this view as I was working with the architects to have a rooftop research platform. And as I switch a hat later on into my presentation about showing you what I actually do, you will see why this is important to have a rooftop research platform. And it is, press the wrong key to go forward. What is very, very important is that as we are considering aspects of sustainability, whether it be batteries that are replacing lithium batteries, whether it be alternative solar cells, whether it be algal growth or anything, we need to consider how it actually works in the ambient environment. And I'll admit to this set of alumni, this takes me back to my industrial days when I had identified that something that Xerox Corporation had developed, yet they were moving it forward, but I mentioned to them, you haven't checked its actual stability in the ambient environment. When we took it out, it died. Oops. Then had to fix the technology. What is more important as we're moving forward with the development of sustainability aspects, whether it be energy storage like batteries, whether it be energy harvesting like solar cells, let's make sure at not necessarily day one, but very close or very early in the development, that it has ambient stability so that it can go into the general environment instead of just working within a research laboratory environment. So we're going to be having this rooftop research platform, and we'll be right beside the solar panel arrays that I've shown you here highlighted in blue, and I'll show you again in the actual picture, in a picture coming up in the next slide. So the other aspect of this solar panel array, and because at the University of Toronto we have a significant cohort that are working on the PV space / solar panel space, is that we'll be able to integrate prototypes into this PV array and then compare even their data against an established PV array to really identify their potential to enter into the market and address sustainability. So here, if you are a bird and flying towards the SLab, here's what it will look like. And you can see again that we've looked at the harvesting of photons in order to actually get lighting into the laboratories. And we have also considered other aspects of photonic flowing into here to ensure that it does not get too hot in the summertime, and or gives us a bit of heat in the wintertime, because if you're not currently living in Toronto, I suspect you do remember when you were here that we have that nice hot summer and that nice cold winter, which gives us that flexibility to either ski or get into the water and go for a swim. Okay, so then if we go through the windows, here's what the inside of the SLab is going to look like. And it is going to accommodate approximately 35 to 40 students / researchers. So, and that is specific to the wet area. If we go over then to the dry area / office area, that we will also be able to accommodate approximately 30 other researchers into this space as well. So to put in context, we will be having a significant number of students or postdoctoral fellows that will be working in this space, and again will be from multiple disciplines, and therefore will be able to have those social connections so that they also understand and appreciate an alternative discipline, or they are working on a cross-disciplinary project. Now, of course, I'm not talking about the pandemic and our limitations of social connections, because this is our goal, is to have good social connections amongst our students in the SLab. So one thing, of course, that we did with our engineers, that we were working together with the architects, is we were looking at our solar panel array, an appropriate area of the solar panel array, and therefore giving us enough electrical power / electricity to power the laboratory over the time of the year. And based on our calculations, we are now very confident, and based on how much energy we need in the laboratory, that we will have a net zero footprint of the laboratory based on the solar array. Now you can see here the distribution. Obviously, you get more power throughout the summer and less during December, but that's what it is in Toronto. But as we take the sum of that over the annual year, it does look like that we will be able to have that net zero footprint, which is really nice, frankly, to know. Now, the other thing that we do want to do moving forward after we do build the SLab is we want to then also consider additional power energy sources for broadly the Wallberg Memorial Building. So we may literally extend the solar panel array all throughout the roof of the Wallberg Memorial Building. But for now, we are just going to be building it relevant to the space of the SLab. The other thing that we have considered, and as alumni, you may be aware that right now there is an ongoing project centrally to have the geothermal system in place within the University of Toronto. And one thing that we have put into this design is that the SLab can be connected to that system once it's already in place. And so therefore we were also looking at a general energy footprint, not just the electrical sources that I mentioned with the solar panel, but also when it comes to heating and cooling of the space. So we've worked extensively well with the engineers that we have hired, as well as the architects, and we really are confident that we can meet that so-called net zero energy footprint for the SLab. Now, for the next slide, what I'd like to show you is that we have really established a significant list already of people that are very interested in cross-disciplinary research and development across multiple departments. And highlighted in blue, this is within the Faculty of Applied Science and Engineering. And you can see that within ChemEng, within Material Science and Engineering, within Mechanical and Industrial Engineering, within Civil Engineering, and within Electrical and Computer Engineering, we have formed a significant array already, and it is growing in time. so this is as of today, frankly, but I know it's going to get even bigger, of colleagues of mine that are interested in cross-disciplinary research and development when it comes to SLab, and then highlighting the sustainability of certain aspects. And it's really going nicely and broadly. So for example, with Murray Thompson, for example, it's going to be going into alternative biosourced fuels, for example, which is a potential sustainability aspect. If we're talking Amy Baslak, for example, her and I'm going to highlight this later too, are very interested in hydrogen generation for an energy source, and that's an example. And then one other thing that we have noted and highlighted, or in this slide, or I have noted and highlighted, pardon me, is that we've already connected with UTM, which is our Mississauga campus, with 2 cohorts that are there that are very interested in joining the SLab as well, as they are dealing with algal growth. And that is another potential source for a biofuel. And then even within arts and science, we have already started connections. And Dwight Safaris is one example. He is a very good chemist out of the Department of Chemistry that is interested in very fundamental chemistry, but is also very interested in applying those aspects to things of sustainable energy. So we have formed a very nice cohort. And just highlighting here as well, alternative set of people that have already identified their general interest of connecting together. And here are the colleagues that are sort of sub-teams of our SLab. So here is then just the highlighting and endpoint of the SLab, is that I will also highlight to you that myself and Professor Grant Allen had applied to the faculty for financial support for the SLab build a couple of years ago, and it was granted by the dean and the selection committee for a 50% financial support for this. And the reason the committee had agreed upon it was because, again, of this significant aspect of being able to facilitate cross-disciplinary research towards all aspects of sustainability. And the other thing is that not just myself and Professor Allen, but that set of sub-teams that I've shown you, or that broader team that I showed you, in general, all of these people have that general feel that we're committing to have that excellent educational experience for our students, so that if, for example, here is one that is definitely interested in the electrical engineering aspect, but at least they have that opportunity to understand the alternative disciplines and maybe even highlight some interests in some of those other disciplines. And then as they enter industry, graduate from the University of Toronto or whatever it is, that they then have that experience. And maybe that's even analogous to myself back in my industrial days, where I did work cross-disciplinary as well and was very interested to me. So the last thing to highlight about the SLab in general is that we did receive a credit from the University of Toronto to move forward on this build, but we are still looking to have support for the infrastructure and or the operational aspects of the SLab, because again, we got a credit and we are still looking for financial support for the SLab. And we are looking to potentially name it as well, outside of just the term of sustainability lab, but also if we, for example, have significant financial support, some people have that opportunity to have it named after them. So as I just check the time, I think the timing is appropriate, because the next thing that I'm going to do is walk down this hall and switch my hat a little bit just to show you why me, for example, have the credentials to be the leader for the SLab and or the leader in chemical engineering and applied chemistry. And as was highlighted by Lori at the start, for example, one of my focal points is on the organic electronics front, whether it be the LED display technology or the organic solar cell technology. And just for a brief highlight, I'm going to focus on the organic solar cells for now. For the OLED display technology, I also have a startup company based out of the University of Toronto in this space, and it would be really nice if our chemicals end up on your smartphones as the OLED technology moves forward. Now within my laboratory, and you can see here's an example of a couple of my past students where they're taking the organic solar cells onto the roof of the Wallberg Memorial Building in downtown Toronto, or showing the prototypes of the organic solar cells. But my laboratory is a very broad research laboratory whereby we do the material synthesis and basic applied chemistry, do the physical chemistry and characterization and the integration into the organic electronics space, and move them forward to the ambient environment to really justify the research and development that we do. So for example, as you see Hassan, my past student on the roof, he is justifying further development by showing that these organic solar cells actually work in the ambient environment. And that's a very important aspect, in my view, for this field. The other thing that I do is I do integrate computational modeling into our materials development. And I would say, or classify it as pseudo machine learning at this point in time. So here are our materials that we have really identified as being very nice, very stable in the ambient environment, and very sustainable chemicals. And given today's presentation, I won't go into super in-depth, but I will show you shortly even a pathway forward to more sustainable aspects of these materials. But you can see with just 2 molecules, we can basically capture 80 to 85% of the visible spectrum from the sun, which is really nice because we only need these 2 materials to do so and can harvest the sunlight. And here's the architecture of an organic solar cell shown here. The active layer, which is colored in purple on the left bottom, is actually a nano level layer. So the benefit of the organic solar cells is that we only need minimal amount of materials to harvest the sunlight, versus if we're talking silicon panels, they are in the micron range, pardon me. And therefore, for organic solar cells, we need far less mass of a material to actually generate the electricity from the solar array. And you can see here then also we have shown they work in the winter time in the downtown Toronto on the roof of the Wallberg Memorial Building. And we have considered multiple architectures moving forward to really show that they can be moved forward to industry. And we've looked at so-called bulk heterojunction, the planar heterojunction, and then also, and our paper was just recently approved, was the solution casting architecture. So we really care about multiple aspects. And here were our first prototypes that were actually put on the roof of the Wallberg Memorial Building in 2015. And these are pictures of 2015. And what was really nice was that after we got back from the pandemic shutdown, we took our 2015 and 2016 and many other prototypes onto the roof of the Wallberg Memorial Building, and they're still working. So we've also highlighted that organic solar cells have significant potential lifetime beyond 5 years. And given how cheap they are, then it'd be beneficial. And then one thing that I really care about is the general sustainability of materials. And so I've also identified a pathway from biosourced chemical to our boron subthiocyananes shown here. And I'm very interested in this space, moving on this space, and not against the petroleum space. So you can see that our original source is the orthoxylene from the petroleum space, and it unto itself, even if we're considering it from a chemical engineering perspective, is a very sustainable chemical process to move forward to the boron subthiocyananes. Very easy. Now, going from the biosource, this means here's a sustainable source. What if we can get something, for example, from corn waste? Because as Canadians, we build a lot of corn every year and with a lot of waste. Is there something I can extract from there and bring it forward to ours? And I have identified this pathway. So the last thing that I'd like to highlight to this cohort is that also I have significant international collaboration points. The first one that I'm going to highlight is with the Technion University out of Israel. On the left-hand side, that is myself and Professor Zeev Gross from Technion University, and it's a pleasure working with him. We are very good friends, and we are making significant progress on considering the organic solar cell architecture / design for Israel, which is a very different environment than downtown Toronto, Canada, for example. And we have been collaborating for a portion of time now and have made significant progress. Students have come to Toronto, students have gone to Israel, we've been working, we have published some fundamental papers, but have also been working really well on the development of intellectual property. And we are progressing in not only the organic solar cell space, but we have identified that we've developed our materials that can actually be hydrogen generation catalysis so that we can generate hydrogen as an energy source. And we've identified a biomedical application, and that's why you can see my picture on the bottom left where we're at Caltech, and we were talking about the medical application for the materials. So working with international collaborators out of Israel is such a highlight, frankly, and Professor Gross is one. I also have a collaboration with Professor Leon Kronik out of the Weizmann Institute out of Israel. Being on that institute was also a pleasure, and should the pandemic not been in place, I would have been back there 2 to 3 more times. And I was even able to go into the original organic laboratory shown at the bottom that was originally built in the 1940s. Now, of course, not a safe laboratory, but they keep it just for historical purposes, where this was the first fundamental organic chemistry laboratory out of Israel, and it was such a pleasure. So I really like my 2 colleagues out of Israel that I get to collaborate with, and with Professor Kronik, what we're collaborating on is on that computational front, so that we can move forward with stronger computational aspects for further materials development. So it is possible also, as we move forward, that the 3 of us, Professor Gross and Kronik and myself, will be collaborating in a very, very strong way with international exchange of students and for technology development. I also have a collaborator out of Denmark, and here it is, Professor Nelsons, shown here, and his first name is Mogens. And the reason I'm collaborating with him is because he actually highlighted my work at the University of Toronto, became very interested in it, and assigned a number of students to the boron subthiocyananes, as you can see here, and I've met her as well. And therefore, we hooked up and became collaborators as well. And he is a very good professor out of the University of Copenhagen in Denmark. So to end my presentation, I'd like to also highlight to you that the norm of my group is always to be a diverse set of students, wherever they're from and whatever they are. We've always had a very nice diverse set. And here's an example of them for a period of time. And it's always nice to also be with my students, frankly, as you can see me smiling with them all. So alumni, again, it's a pleasure to be with you today. I'd like to thank you for your time and would love to answer any questions that you may have about the SLab and its build and our focal point within the faculty and any other aspects that you'd like to raise. And I thank you. And Laurie, I'll turn the table over to you.
Thank you, Tim. Actually, we have a lot of questions which are coming in. We won't be able to cover them all in the interest of time, so let me begin quickly.
Okay.
Ursula Adich asks, how much of your research is supported by Canadian industry or government?
Okay, so the Canadian government has a very good support structure, and I have been able to apply for it and be granted to it. So yes, I've been having very good support within Canada for the development of the technology. Yes. Mm-hmm.
Good.
Yes.
Another question also for Ursula, is the SLab considering research and development on carbon capture?
Yes, indeed. So one aspect that I could highlight to you is that we have a couple colleagues, one within mechanical engineering, Dave Sinton, and one out of electrical engineering named Ted Sargent, that are working on the reduction of CO2 into chemical sources. And Professor Sargent has recently identified that he could take CO2 directly into a polymer, for example. So that is something that is ongoing within our faculty, yes, and would be relevant to the SLab, yes.
Thank you.
Mm-hmm.
Another question from James Wong. Are you doing much research on plastic recycling or electronic waste recycling?
Mm-hmm. So within the university, and the recycling of the plastics is actually a very broad topic that does need multidisciplinary aspects. So I'm actually involved in that as well, because I actually also have a polymeric background that does include my industrial days and does include research at the University of Toronto. And there is a central strategic thing going on to define what the University of Toronto can help with the recycling of plastics and or the environmental aspects of plastics that have been highlighted by society. So the University of Toronto has that ongoing. I don't have anything from a research perspective to show you right now, because again, where we are is to truly define what impact the University of Toronto can have, because we don't just want to do, oh, here's a basic thing, here's a degradation of the polymer, whatever. We want to have a very broad impact, whereby we have a multidisciplinary approach where we work with environmental scientists, we work with other arts and science people that can help on policy type things. Maybe we do develop an alternative plastic from a biosource or something. So we're currently working on this because we want the University of Toronto to address this problem that society has on plastics.
Thank you. A somewhat related question earlier from Walter Kraus. Is there any consideration being given to harvesting organic wastes from the university community to feed an on-site biogas system?
So that is correct. I have a colleague named Kathy Chin. She's a professor as well, and she actually has an industrial support to develop catalysis to take organic waste and have it go on then to a fuel source. So we're doing that as well. Yes.
Thank you. Question from Ernie Springolo. You mentioned that for the research, quote, products outcomes, you will be able to assess ambient stability at the SLab. Will you be able to assess the potential manufacturability of these outputs as well, or will you be looking for industrial partners?
So actually, very good points, because for sure after we do the ambient environment, and for me as a PI, you notice that I focus on also a way to manufacturability. So I have other colleagues that do that as well. And then we have two potential pathways. The first is that there is an industrial partner within Canada or has a footprint in Canada that we can then connect with and move things forward. So for example, in the battery space, we foresee that there are companies within Canada or even outside of Canada that we can then move the technology forward with. And within the Faculty of Applied Science and Engineering, many colleagues do not just do this basic research. They always think, is this industrially viable? Okay. On the flip side, we also have within the Faculty of Applied Science and Engineering something to enable entrepreneurship called the hatchery. And that was when I had identified an OLED technology. There was no LED footprint really within Canada, and I started a startup company as well. So I will just highlight, not just as myself, but for this entire faculty, a high chunk of our colleagues are keen to get things out of the university to impact society, no matter whether it's plastics, waste, water purification, many aspects. It's a major focal point of this faculty.
Good. There's a somewhat related question, speaking of partnerships, for Nalita Nadarajat. Is the SLab part of Earth, the environmental and related technologies hub that is being planned at U of T Scarborough in partnership with Centennial College?
So for right now, we don't have that connection yet, but that's what we are doing. And moving centrally, for example, as we've had significant support within the Faculty of Applied Science and Engineering, and now we're moving outside of the Faculty of Applied Science and Engineering, definitely we'll be hooking up, and you can see we've already hooked up with the UTM Mississauga, and we will be hooking up with Scarborough as well. So we're aware of each other. We just don't yet have that formal connection, but it will be in place. Yes.
Good.
Because maybe even just to highlight, Laurie, too, like even as I was showing those pictures, maybe I should highlight like where we are with the SLab is we're going to be going for tender on April and starting to build basically in May. So we got a lot of things on parallel right now to get those connections in place. And that is definitely one that we have and will form. Yes. Thank you.
Good. I don't know whether the next question is from a potential partner, Param Zabedi, who did his master's in alternative aviation fuel emissions under the supervision of Professor Murray Thompson, who we understand is part of the SLab team. Since graduation, Param has been working at Pratt & Whitney, Canada, in the aerospace industry, obviously, in Mississauga. And he is wondering, one, how Pratt & Whitney, Canada can contribute to the current or future projects at the SLab in aviation. And second, if there are any projects in general by SLab in the aviation space where they're moving towards battery-driven or electrical jet engines or aviation jet fuels. Wow,
great set of points, frankly. So as of right now, again, as we're building the SLab, we're looking, or we will take things from both perspectives, okay? So if, for example, an industrial partner approaches us because they feel that they would like to leverage the capacity of the University of Toronto to help fix a gap that they have, consider a technology that they would like to have and move it forward or something, please approach us, because that is also why the SLab is there, for industrial partnerships. And it's not that we are just going to go out to a specific industry, but if, for example, you as an alumni come back because for your company, you would like to consider this, I'm very confident that we will have a sub-cohort of professors that could identify this for you. And you're absolutely correct that based on what you just defined in the aerospace area, that is definitely related to sustainability. So we can do that, okay? Like when it comes to ongoing projects, that is the other opportunity, because many of professors, myself and others, get base funding from the Canadian government and then have identified an actual technology, then will approach industry and say, hey, I've got this one. Can we work together to get it out? Okay, so we can do it in either direction. Okay, Laurie?
Thank you. The next question is from my colleague, Jim Courtney, who's a fellow colleague on Lunch and Learn. And he asked the question, in other buildings, there is an emphasis on rooftop gardens or lawns. How does this concept, meaning the SLab concept, reconcile with Toronto's mandate to have rooftop gardens?
So that's a good point, because I think the old building of architecture has a rooftop that aspect. So I know what you're referring to when it comes to the growing of things on top of a roof to help the sustainability aspect. But our goal point here, again, is to have that outdoor laboratory in order to have a environment that has all of the resources where we can bring something out to the outdoor environment and get its data acquisition and its general understanding of its operational aspect in the environment. So I don't think it conflicts with that aspect City of Toronto is asking people to do. I don't think so. Yeah.
Good.
Yeah.
I have another question also from my colleague Jim Courtney.
Okay.
Would you be applying for Elon Musk's newly announced $100 million contest for carbon capture technology development? They are looking to support multiple teams, and perhaps yours could be one of them.
Yes, so my understanding is that as Dave Sinton is leading that aspect, that he is applying for it. Yes, indeed. Great. So he's really focusing on the electrocatalysis of the CO2 reduction, and he's been making great progress, frankly. Mm-hmm.
Great.
Yes. So that like my focal point again is going to be, or still is, solar harvesting and the generation of hydrogen as an energy source. But again, we have this other cohort that is definitely moving onto the CO2 reduction point to try to get that CO2 out and affect our climate change. Mm-hmm.
Good. While we wait for online questions, I will return to one or two of the questions that were submitted in advance. One from Gavin Rodriguez. One challenge of all organic materials is their degradation / oxidation over time in application or the environment. Is there any way to address or mitigate this issue without resorting to using inorganic materials? And is there any advantage of using organic materials when an inorganic alternative exists?
Mm-hmm. So very good question. And should I unshare my screen so that the cohort can see a bigger point of my face? Is that okay? All right. Okay. Because I think then like you'll see myself and Lori as we're talking a bigger face, frankly. Okay. So your point is absolutely something that we have addressed with our materials. And what we have identified is that we have a very simple encapsulation methodology that enables the lack of oxygen diffusing into our materials and causing oxidation. The other thing that we have done is actually found out that our materials, based on their stability, don't actually take on oxidation. But you're absolutely correct of your understanding of organic materials, that in general oxidation, and whether it be based on photoexcitation and then the presence of oxygen, undertakes oxidation. We frankly just don't have that with our materials, which was nice to find, frankly. So it has been a major research focal point, and you're absolutely correct with it, that that's something one needs to consider when it comes to organic materials. Mm-hmm. Yes.
We just had another question posted online. Anaki Muhammad Effendi, what is the name of your OLED startup? Is it looking to hire PEY students? I think the technology is really cool and I would love to be involved.
Mm-hmm. Well, he's free to reach out to me separately on that point, frankly. So it's called Amber Molecular, and it is on the first stage of investment. Okay, so it is possible to have a PEY hire, but you should probably reach out to me individually on that. Mm-hmm. You know, because as a co-founder of Amber Molecular, obviously that's different than my role as a professor here and the leader of the SLab. Okay. Mm-hmm. Yeah.
Let me see if there are any other questions.
Mm-hmm. Well, it's a pleasure to hook up with you alumni, and I'm open to stay past 1 o'clock. I know we're only 1 minute to 1. And it frankly was even a dream I had last night on sleep. Was such a pleasure to hook up with the alumni. And I hope you appreciated too that international aspect that I mentioned just for myself, where I have that significant and awesome collaboration out of Israel, because I've heard that some of you that have joined today are joining out of Israel. It's a pleasure to be in Israel and working with them. But for the SLab as well, and I may not have highlighted that in my presentation, is that it will involve international exchanges as well, as we're considering collaboration points, whether it be with industry, here's an industry out of India, and therefore we bring in, whether it be industrial people, or if it's a collaboration point with a professor out of India, and just using India as an example, then we will be bringing in professors and or students as well. So,
Thank you. Since we are
yes.
approaching the top of the hour, let me begin by closing the formal part of our presentation. As we indicated earlier, Tim is willing to stay and chat informally and answer any additional questions. But I would like to thank you for all of the questions from our audience today. We've really had many, many questions. And obviously, before I close, we want to thank Professor Bender for being with us today, and that we invite your feedback on School Lunch and Learn. A link to an online survey will be made in the chat box and will be shared with you after this event as well. Also, we will be sharing a link to Professor Bender's presentation to all those who registered earlier this week. The School Lunch and Learn events are traditionally hosted on the second Wednesday of each month. Sadly, I would say we'd like to meet at the faculty club, but that is not on these days. Our next Lunch and Learn event will be on Wednesday, March 10th. This annual event will be the School Lunch and Learn Award Ceremony, celebrating the student recipients of scholarships and awards from the class of 5T0, 5T3, 5T6, and the 3T5 Second Mile Award. We would also like to acknowledge and thank our MBNA, who are the sponsor of School Lunch and Learn through U of T's Pillar Sponsorship Program. And if you're interested in learning more about School Lunch and Learn, you can email the alumni office at events@engineering.utoronto.ca. In closing, I would like to thank all of you for joining us today, and I hereby adjourn the formal part of Lunch and Learn. Have a safe and healthy day for those of you that have to leave us. And if you want to stay and chat with Professor Bender for a few minutes, you are welcome to do so.